Physics is an experimental science where we use observations to generate theories that we then can use to predict what will occur in the future. Patterns are observed, data is collected, and over time theories emerge. Those theories are tested over and over and over again. And if those theories are proven to be true or shown to be true over and over and over again, then those theories become laws. For example, Galileo Galilei, one of the most important scientists, used experiment and observation to determine that two objects of the same size but different masses fall at the same rate by dropping two objects that were similar. Physics in general is always dominated by observations, and so we're always going to observe and then use those observations to determine a prediction, to determine a relationship between variables. Particularly in this class, we'll be discussing motion and things that are moving. Physical systems, as we try to understand them, can become complicated extremely quickly. Imagine just the act of hitting a baseball. If you hit a baseball, the ball goes up in the air, and at some point it's going to land on the ground. In general, we understand the physical principles that determine the motion of that baseball. The problem comes in when we try to understand all of those physical principles all at once throughout the entire motion of the ball. So of course the impact from the batter hitting the ball into the air is going to determine where the ball goes, but also the wind speed, the rate at which the ball is spinning, the angle at which the batter hits it. And without a lot of time and a lot of extra math, it would be a really complex situation to solve. So instead of doing that in this class, we're going to work to understand the basic physical principles and just investigate them one at a time. Deal with the simplest motions and try to understand what's occurring in those situations to understand how we could extrapolate that to larger situations while not actually doing that.